11.5 is trig word problems level 1. So a lot of what might show up on, say, an ACT or something would be some of these problems that involve trig. They're not going to tell you that, but you've got to be able to draw a triangle that goes with the problem and then use the right trig ratio to solve. Number 1 says Layla leans a 26-foot ladder. So a ladder is going to be going to be the hypotenuse against a wall so that it forms an angle of 61 degrees with the ground. How high up the wall, so how high up, that's a vertical distance, the wall does the ladder reach? Round your answer to the nearest tenth of a foot if necessary. So my ladder is going to look like this. You label as much as you want. And so what it's doing is it creates a vertical height with this is the wall. And then this would be the distance on the ground. So I know, like in real life, you're not going to have something actually here. This is just representing the ground. And we want to know how high up the wall does the ladder hit. So this is going to be my side X. We also know that the base of the ladder is forming a 61 degree with the ground. So that would be this angle right here. If it said the angle of the ladder formed with the wall, that would be here. This is our 90, so they're never going to say that. Okay, so from here, oh, and I gotta label my ladder. Ladder's 26 foot. So from here, this angle I've got opposite and hypotenuse. Opposite and hypotenuse would be sine. So sine of my angle would be the ratio of x to 26. And then all you gotta do is multiply by 26. Again, you might need to check your mode of your calculator. Remember, it's that second button. Just double check to make sure you're in degrees and not radians. 26 times sine of 61 is that, and what did it say to round to nearest tenth? So that would be 22.7 feet. So that would be this height. All right, number 2. A boat is heading towards a lighthouse. So think about that. A lighthouse is something tall. And then a boat is going towards it, right? So this is your boat. It's going towards it. Whose beacon light is 139 feet above the water. Beacon light is that light that's on the top of the lighthouse that shows the boats where it's at and where the shore is at. So this is a vertical height of 139 feet, sorry. The boat's crew measures the angle of elevation. An angle of elevation is from something down lower looking up to something higher. And it then creates this angle right here. Because this would be an angle of 0. Picture this opening up like a door hinge. That creates an angle of elevation. And then what is the ship's horizontal distance from the lighthouse? So how far horizontally is the boat from the base of the lighthouse? That would be the side we're finding. So from this angle, we have opposite and adjacent. We do not have the hypotenuse. So opposite to adjacent is tangent of 11 degrees would be 139 over x. Remember the shortcut, instead of multiplying by x and then dividing by tangent 11, really these two things switch. So x is found by taking 139 divided by tangent of 11. And so that would be 715 point, nearest hundredth, 09. Make sure you're reading what they want you to round to, because Delta Math likes to switch it up on you. And that was feet. Number 3. Miguel is flying a kite, holding his hands a distance of 3.5 feet above the ground. That's going to be important. And letting all the kite string play out. That just means there's no slack in it. He measures the angle of elevation from his hand to the kite to be 25 degrees. So let's just think about that too. So here's our person, Miguel. He's holding the kite from his hand. It's not from the ground. And so the kite would go up at an angle like this. And then our triangle then would go horizontally out from where he's holding it to make a 90. And so his hands here to here is a 3.5 foot distance from the ground to his hands. The angle of elevation, so again, would be from somewhere lower looking up. That would put this angle right here is 25 degrees. The string of the kite to his hand, so that would be this angled this angle distance is 150 feet long. How many feet is the kite above the ground? So with this triangle, all we can find is this side. But if he wants to know from the ground is technically down here. So you're going to have to add, it's going to be whatever x plus the 3.5. Okay, so that only happens when something is up higher and our triangle is not formed with the ground. You have to add. Okay, so we've got from this angle opposite and hypotenuse, that would be sine of x over 150. Oh, I didn't put my angle, sorry. Sine of 25 degrees, excuse me. Got ahead of myself. Is opposite x over 150. Multiply by 150 on each side. And that is 63.39. I'm going to keep that another decimal place just so I can add. So that's what this is. Now add 3.5 to that. And I get 66.9 feet. Right, and number 4. From a hot air balloon, Nayeli measures a 35-degree angle of depression to a landmark that's 905 feet away, measuring horizontally. What's the balloon's vertical distance above the ground? Okay, so something is up high, this hot air balloon. Don't laugh at my drawing here. Okay, that's not good. You know. Okay. Hot air balloon. And they're looking down to a landmark that's 905 feet away. When they say something is 905 feet away, they're not measuring this angle distance. They're actually measuring from where this is, so here, horizontally to where the landmark is. So that's where I'm going to put the 905. The angle of depression, this is very important. Angle of depression is actually formed from something up high looking down. So that puts it here. But that's not even inside of our triangle. So actually this line that I drew, this horizontal, and then this ground, they're parallel lines. And remember, parallel lines can create a transversal problem when you have a line drawn through them, which would then say this angle is actually the same as this angle because they're alternate interiors. So really an angle of depression becomes an angle of elevation when you're looking from the ground up. So kind of cool. Okay, and then what else do we know, or what are we trying to find? The balloon's vertical distance above the ground. So I don't need to add anything to it. My triangle is created with the ground. So from 35 degrees, I have opposite and adjacent. That would be TOA, tangent, of 35 is x over 905. And so all I got to do is multiply by 905. And I get, here's 10, 633.7 feet. And that's it.